I'm James Robinson, and this is Multiverses. Science is populated with some wonderful objects: black holes, quarks, wavefunctions, and even the humble electron is so far beyond our everyday experience that we can't straightforwardly see it. For a long time, philosophers of science have worried that these out there objects aren't actually out there, and that science doesn't even claim that they are. Rather, these are convenient fictions, things that help us crank through equations so we can arrive at real, tangible predictions. This is the position of the instrumentalists. And on the other hand, you have realists who say, no, if something is in my best theory of the world, then that theory is claiming that it's in the world itself. But why don't ask physicists themselves, what do they believe? Our guest this week is Céline Henne. She's a philosopher at the University of Bologna. She was recently at the University of Toronto, and she and her colleagues have done just that. They have fielded, I think, the most comprehensive survey of scientists' attitudes, of physicists' attitudes to this realism, instrumentalism debate. And it's a really carefully constructed survey. They don't just ask, are you an instrumentalist or a realist? There are dozens of questions to tease out the distinct positions. Things like, are electrons real? Are electrons as real as toenails and volcanoes? And many other questions not to do with electrons. And the results are, in some ways, unsurprising. Most physicists are realists, spoiler, but actually, in other ways, they're quite intriguing. So there are a lot of physicists, it turns out, who are instrumentalists. That's a really significant subgroup. About 15% of physicists are instrumentalists. And there's many other nuances that are uncovered in the data. There's many subcamps, distinct positions, people like perspectival realists. And the wonderful thing about this survey is that by having so many questions, they're really able to tease out the positions. So I think this is a fascinating introduction to this age-old debate of instrumentalism versus realism that offers new data and makes us ask, is it perhaps important that people have a mix of views when doing science? Or perhaps is the fact that physicists can be, instrumentalists or realists, does that just show that it doesn't matter at all what perspective you have? If you want to take this survey and find out if you are an instrumentalist or a realist, you can do so. There is a link in the show notes. The link is scientificrealism.multiverses.xyz. And with that, I hope you enjoy this discussion as much as I did. Céline Henne, thank you for joining me on Multiverses.
Hi, James. Thank you so much for inviting me.
So we're going to talk about realism and specifically scientific realism and other positions that we can take towards science. So maybe we can just set the scene. Like, what are the different ways we can think about what claims science is making?
So there is maybe a simplistic way of thinking about two opposing positions on the debate about what science is about, what it is doing. So on a simplistic version of scientific realism, we're saying that science is about accurately describing the world as it really is, including the underlying order of things. So beyond what is merely observable, can we get to the deeper secrets of nature and how it works. And the claim of scientific realism is that our current science is successful in doing so. So that doesn't mean that everything that science says is true or that all of our theories are completely true, but they're at least our most successful scientific theories are approximately true. So we shouldn't expect future generation to completely discard what we are saying about the world currently. And then the opposite position would be that science is not about describing the inner layers of nature. It's about constructing tools or instruments that can successfully predict and systematize observable phenomena. And what they're talking about, the kind of entities that they're talking about that are unobservable, should not be interpreted as really existing out there in the world. They're just useful ways of describing and predicting phenomena. And so we should, on the contrary, expect that future generations might come up with new theories that will overturn our current theories in the same way that past scientific theories that scientists used to think were true are now considered at least only partially true. And so this is a very simple way of setting the debate. Currently, of course, in philosophy of science, there is a lot of nuance, a lot of different positions that emphasize one or the other aspect, or choose to add more complexity to these views. But this is
not surprising that once philosophers get their hands on things, they find more complications, right? But I think that sets us up well, and I mean it emphasizes that the anti-realist stance, or the classic anti-realist stance of instrumentalism, it's not just the same as general skepticism. Like there's this very long history in philosophy, obviously, of doubting everything, and the instrumentalist is not in that business of saying, no, maybe I don't exist, maybe this table isn't here, etc. They're in the business of saying, look, science, of course, claims that it's making about what the planets are doing and things like that, and how a projectile will move. That's that checks out, right? I can get on board with that. But when it gets into, I don't know how many dimensions there are, and what strings are, and quarks, and things that are just so far from experience, I don't need to believe in that to get the benefits of science. And maybe science isn't even trying to deliver me those things, right? It's not trying to claim this stuff is really real. It's and the kind of classic phrasing is it's a useful fiction, I guess. So, and you mentioned this kind of observable, unobservable distinction, which is always a bit of a thorny one, and maybe we can go into that in some more detail later. But I kind of want to start with this paper that you have as I guess it's been accepted, so and one can read it as a preprint, and it's this wonderful survey of what it is that scientists and philosophers actually believe. And it's a really nicely designed survey, because you're not just asking them, oh, are you a realist? Are you an instrumentalist? Which, I mean, many physicists probably wouldn't even think in those terms. But you've got a very concrete set of questions which tries to tease out what is the position that someone's holding. So, I mean, maybe start by what was the motivation for trying to find out what physicists specifically actually believe?
Yeah, so I mean, it started during my PhD. So this survey was done in collaboration with my colleague and friend Hannah Tomczyk, who was doing her PhD with me in philosophy of science at the University of Cambridge, and Christoph Sperber then joined us for the statistical analysis part of the survey. But it basically started in our discussions that we had with our working group, with our supervisor, and we had a reading group on scientific realism, and so we were discussing a lot of these issues together. And Hannah herself is a practicing physicist. She has a PhD in quantum optics and atomic physics, and we were the question of what physicists believe actually came up quite a lot, and we were all relying on anecdotal evidence, either for those who were practicing physicists talking about themselves and what they believe when they're working in lab, or what their friends believe, and so we were really curious to know what would be the majority view among physicists, what would be the majority view amongst experimentalist versus theoretical physicist, or whether there would be any distinctions about this. And we also noticed that in the literature, some claims are sometimes made, like it would be crazy not to believe in the existence of electrons. Obviously, all physicists believe in the existence of electrons. Or physicists are not realists when they practice their science. They don't think in those terms. They don't think about these issues. So we were just curious to have a broader picture and a little bit more accurate picture of based on a bigger sample size, basically.
It's lovely to see philosophers kind of getting out of the armchairs and trying to get some data on the world.
Yes.
So as I said, I really like the questions that you asked. So maybe take us a little bit through the kind of the design of this survey and how many respondents and things like that you got and where you found them, and I don't know, any things that you think are kind of interesting to help understand how this worked.
So first, I can say a few words about how the questionnaire was designed, because it was very difficult to design a questionnaire that can get both at the nuance of the views and can be clear enough for non-philosophers, and yet be short enough that we get as many respondents as possible. And I remember in the early days of designing the survey, we wanted to ask so many questions. We wanted to ask what their view of truth was, whether they were thinking about these issues in the same way in the lab or outside of the lab, and it was just getting too complicated. We even wanted to do the survey with other scientists as well, so have specific sections for biologists, neuroscientists, to also compare between sciences. And then we realized that was just way too ambitious. And so we set on, I think that's, 30 questions, which is already quite a lot, but still not enough, obviously, to cover all of the complexity of these issues. So yes, we wanted to pick some statements that reflected some philosophical views, but trying to reformulate them in a way that's accessible to physicists. So about what does physics do? Does it accurately represent the world? Does it tell us about how it works? Or is it merely useful instruments that can help us manipulate and predict phenomena? Then we had specific questions about specific entities, like electrons, and we didn't just want to ask them whether electrons exist, because as many respondents of the survey actually commented in the comment section, all of these terms are hopelessly ambiguous and can be interpreted in so many ways. So we did try to decline this statement in several different versions to get at a bit more nuance about the claim that electrons exist. So do they exist out there independently of our models and theories, or are they postulated as real within a model or theory? Are we getting closer to the real nature of the electron? Are they as real as toenails and volcanoes? That's a quote from Ian Hacking. So we did try to do that with electron. Unfortunately, we couldn't do the same with everything, because that would have made the survey way too long. So it was fun, but very difficult to constrain ourselves. And I tended to be the one that wanted to add so many more things. And Hannah was like, no, wait a minute. Like, we need to make it manageable, also for statistical analysis, because we need to make the questions so that they can be easily analyzed. And that means that we had to make other choices, like for so many of these questions, for example, one view, we try to force an opinion on people a little bit, although we did have a slider, so you could choose between 0, I completely disagree, or strike me as completely wrong, and 100 strikes me as completely right. but we were wondering whether we could have an option that says I suspend judgment, or I have no opinion about it, or this question doesn't make sense to me. Because obviously that can be the response as well. But we just thought there was no way of adding that option in a way that is manageable for then the statistical analysis. So yeah, there is so much more nuance that cannot be captured by this kind of survey, and yet it's still really helpful to get a sense of what people think about certain issues based on a larger sample size. So yeah, about the sample size, we had 384 physicists and 151 philosophers of science, and then a few who were neither, but they weren't accounted for in the survey.
Yeah, that's an impressive. I mean, it's wonderful that you managed to ask so many people about this. And by the way, yeah, it's so interesting that I'd never considered this point that you know some of the it's a very philosophical take on things to say, well, actually, I neither disagree nor agree with this statement. It's just a meaningless statement from my point of view. And maybe we need more dimensions to our sliders. But yeah, just survey designs are not like that. Yeah, so I think like the 30 questions that you came up with, yeah, I can see just how much curation that must have taken. And yeah, it is interesting as you mentioned. Like I think 5 or maybe even 6 of those questions are about electrons. So that's like 20% or something of your survey. But it makes sense because it's such a paradigmatic case in the literature, and that hacking example of electrons are at least as real as toenails and volcanoes. Such a poetic way, almost, or so visceral how he gets to it. But yeah, just to give a flavor of the different questions, at least on electrons, you have like the electrons exist question or statement, and then electrons with all their properties exist out there independently from our theories. Our theories are getting closer to the real nature of the electron. And then here's one which is driving something different. Electrons are postulated as real within our models. It does not make sense to ask whether they exist outside or independently of the theory or models. So clearly that's a kind of, I guess, instrumentalist take on things, or maybe slightly more internal realist, one might say. So you can still be a realist, but you're not buying into all the metaphysical claims that there is a kind of reality independent of descriptions of it. And then this one is very instrumentalist. There is something in the world that behaves like what we would define as an electron, I guess. So yeah, it's really interesting to see, just for this single question, which one might think, oh, just electrons exist. We have to ask so many, or there are many questions that are needed to tease out the different positions that one can take on that, which suggests just how subtle these positions are. Yeah, and of course, I mean, I'll go over some of the other questions because I do think they're so wonderful. I mean, the first one is just our most successful physics shows us what the world is really like. So straightforward scientific realism one. And then there's this question of, if there was a highly advanced civilization in another galaxy, their scientists would discover the existence and properties of many of the imperceptible objects of our current physics, which gets to this question of, not only is science trying to deliver a picture of the world as it is, but it's actually doing a good job, which is, one can have their independent questions, I suppose.
Yeah, exactly. And I actually this question we thought was important because sometimes we wonder what would be a practical implication of saying that that our scientific theories are true, for example, and based on the different views of what truth is, you could get a very different thing. So with this kind of hypothetical scenario, we wanted to get at we thought that was a useful way of testing whether someone is really realist. So they're not just saying scientific theories are true, which could just mean they're empirically adequate, they successfully described observable phenomena, but that the kind of entities that they describe, so the quarks, the photons and the protons, another advanced civilization would discover the same object with the same properties, or would carve out the world in the same way that we do, which has more of a metaphysical implication than merely saying that scientific theories are true, because that also removes the possible contingency of our scientific practice, that we just got at these kinds of theories and these kinds of entities because this is how scientific practice got organized, and this is what we found useful to build in our current historically, culturally situated practices. But if an advanced civilization would get at the same kind of entities, that shows that the march of science is not contingent. We're really getting at the joints of nature, so to speak.
Yeah. I guess if one believes in like a kind of correspondence theory of truth or a representational theory of truth, there's just like there's kind of one way that things are, and either our science is getting us to that, and therefore, and we'd expect another advanced civilization to get to the same thing. But there are other theories of truth, as you kind of point out, and one might just have might claim, okay, well, it's enough for our theories to be internally consistent and produce external observations that are in agreement with everything. This kind of idea, I guess, of maybe Dennett's real patterns, which some people will be familiar with, of if you have a pattern which is really useful in doing things, that is enough for me to call that pattern real. So, and that extends beyond science to things like, I don't know, happiness and intentional states and things like that. But that's a very different kind of idea of truth to the kind of classic, oh yeah, there's stuff out there, and I'm trying to create a map onto that with my words. Maybe we should talk through some of the results, because you suggested some of the things you're hoping to find, like, is there a difference between theoreticians and experimentalists? Is there a difference between philosophers and physicists? So was there? What came out?
Right. So about these questions, we were actually very surprised to find that there were no statistically significant differences between different groups of physicists. So we tested for experimental versus theoretical physicists, physicists working in basic versus applied physics, the different fields of physics broadly construed. And then, so for none of these, we found differences. We did find a difference, weak to moderate correlation between the degree of scientific realism and the time spent in research. So apparently the more time you spend in research, the more likely you are to be a scientific realist. That is the only one we found, and we were really surprised, because we thought that there would be some difference, at least at the level of individual statements, between experimental physicists and theoretical physicists. So, for example, maybe experimental physicists tend to use theories as instruments to perform experiments and interpret data. So maybe there would be more instrumentalists about theories, but then they manipulate entities. And that was one of Ian Hacking's claim, that experimentalists, as they manipulate entities, cannot but believe in the reality of these entities. And so does that mean that experimental physicists would tend to be more realist about those entities that they manipulate? Or on the contrary, maybe theoretical physicists, because they are working maybe more, maybe because they're more removed from scientific practice and dealing with abstractions. And for example, if you deal with string theory, it's maybe you think that these kinds of theories are just speculations. They're not real descriptions of the world, or on the contrary, you think that you're really getting at the nature of the world. So we weren't sure in which direction this would go, but we did think that there would be a difference. So we were really surprised to find that there were none, including for the individual statements about entity realism.
Yeah, I found that really surprising as well. And
Mm-hmm.
as you say, there's 30 questions here, so there's a lot of places where, even if broadly speaking, they both theoreticians and experimentalists are realists, which it turns out they are on average. um,
Mm-hmm.
you might think, well, maybe they're realists about maybe the kind of realism that they have is slightly different, or
Yeah, exactly.
but yeah, across all those statements, they come in very close as groups against one another, despite the fact that many people would think, oh yeah, experimentalists and theoreticians are completely different breeds within
Mm-hmm.
physics. At least they often kind of talk of themselves that way, but maybe there's a lot more. Maybe that difference is overhyped, and certainly in terms of their kind of stances on these issues, they're really surprisingly close, and that becomes perhaps more. One might think, oh well, maybe just everyone thinks alike, right? But then when you look at the positions of philosophers, that's actually quite different. So yeah, maybe talk us through that.
Well, I mean, you said right. Maybe everyone thinks alike, and actually, that's a good point. That it's the opposite. It's not that both theoretical physicists and experimental physicists they all think in broadly the same way. Is that within every group, everyone disagrees. I mean, there is a lot of
Right.
disagreement. So within physicists, within groups of physicists, and also, of course, between physicists and philosophers of science. So one of the idea of the survey, of course, was not just to survey physicists' opinions about scientific realism, but see how that compares to philosophers of science. There had been already a study probing these questions by Beebe and Delson. So they had already tested different stances in within the scientific realism debates between scientists. So their surveys was much broader because it was also investigating views from different scientists,
Mm-hmm.
including so from physicists to anthropologists. So very different kinds of sciences, and as compared with the view of scholars in philosophy of science or history in philosophy of science. And so they had already found that physicists or at least STEM scientists tend to be more realist
Mm-hmm.
than philosophy of science or science and technology studies scholars. And which is not surprising. And we did find a similar result that philosophers of science are slightly less realist than philosophers of physics, but than physicists. But the difference was not as major as
Mm.
we expected. It was so I have the. I'm not sure if I have it here. We calculated the mean. We also calculated different ways of calculating the realism score for different people, and we had similar results based on different methods. So, but from what I remember, just based on the average of the responses, I think we found a difference of maybe 4 or 5 points out of 100, or maybe 6, but it wasn't as major as we thought. Um, the interesting thing is also to see the difference within the groups of physicists. So and actually, it's funny because we already got a sense of this when we were devising the questionnaire, because um, when we were thinking about what type of questions to ask, we wanted to make sure that those were questions that physicists had an opinion about. They kind of had some intuitive sense of whether they would agree or not. And so we had a kind of working group, test group, most of whom were experimental physicists at Cambridge that were friends with of Hannah's. And so we had a few meetings with them when we kind of probed them on different kinds of statements, and that's how we refined also the statements. And already then, actually, they were all disagreeing with each other about what science is doing, what physics is doing, whether electrons are real or not, in what sense are they real or not. And in a way, that was good for us, because we thought, okay, if there is friction, if there is disagreement, it means there's something there, and there is an opinion. It's not just they're randomly saying yes or no, and they're not really they don't really have an opinion. So already then, within this small group of I think it was 10 people, there were already heated debates about what they believed. And the funny thing is that, of course, they had been working together before, and they had never considered those questions together. At least they hadn't debated those questions. They were very surprised to hear about their colleagues' views on the matter, because an interesting thing also is that maybe in the practice of science, it doesn't really make much of a difference whether you're a realist or an instrumentalist. They were obviously both very successful physicists, but yet with sometimes widely different opinions about on the matter.
Yeah. So I think this comes to an important point. So yeah, we said, okay, well, as a group, the kind of average scores of theoreticians and experimentalists are very close, and kind of overall realists, and then the philosopher scores are a little bit lower, but still quite realists, perhaps surprisingly. But that's kind of like the devil is in the details, because the group scores, which are just simple averages over everyone, hide the fact that there's all these kind of like cliques within the positions, and that's kind of where you can see these internal disagreements taking place. Whereas perhaps two people both might answer yes, electrons exist, but then they might answer the other questions about electrons differently. So yeah, how did you kind of go about identifying some ways of clustering the views together?
Yeah, so one point of the survey was to see, of course, beyond the average, what the average physicist thinks, whether physicists cluster in some groups that can be philosophically relevant or interesting. And so we performed a cluster analysis. I mean, I say we, of course, it's Christoph Sperber who performed all the statistical analysis. And so, I mean, I'm not going to be able to give much detail about how cluster analysis works, but the main idea is to find ways of clustering the physicists so that to find the optimal number of clusters, because obviously you could arbitrarily decide to find a clustering solution for 2 clusters or for 6 clusters or for 10 clusters. But you need to find the optimal number of clusters first. So I think at the very first time he performed the analysis, he did it with 3 clusters and found something good. But optimally, you want a cluster where there is as little variation as possible within the cluster, but as much variation as possible between the different clusters. And so we landed on 5 clusters that apparently was the one of the best ways to to separate these physicists into different groups of people who were more like-minded or thought in a similar way. And then and so yeah, that was interesting. We found pretty unsurprising clusters. So the very instrumentalist clusters, so groups of physicists that tend to disagree with the claims that our most successful physics shows us what the world is really like, or that our theories are true, or that we discover imperceptible objects rather than construct them. And then we had, of course, the standard realist cluster of physicists who agree with all the real statements, strongly disagree with all of the instrumentalist statements, according to which our scientific theories are merely instruments that help us manipulate and predict phenomena. And then we had a moderate realist cluster, so physicists who tend to I mean, maybe they were just more cautious, but it's the way that they roughly answered the question pretty moderately. Yes, they're true, but not. They don't agree 100% with the claim that theories are true, that they show us what the world is really like. But they were still pretty strongly realist about entities and a bit less about theories. So we thought this cluster was more moderate, but also tended towards entity realism.
So it's believing in stuff like electrons, but not necessarily believing in
exactly. So, I mean,
general theory of relativity.
We can also talk about maybe later about what are the statements that most physicists do agree with, because we did find, beyond the variation between groups of physicists, we did find that some statements were for which the answers were highly skewed towards agreement or disagreement. So where there is some consensus between physicists. But yeah, these entity realists tended to strongly agree with all of the entity realist statements. And then we found a cluster that was that had a combination of some very strongly realist views about science and its ability to describe how the world is really like. Also, very, very strong entity realism, so more than the moderate cluster. So, average agreement of around 90% with all of the entity realism statements, but with still a pretty strong pluralism and perspectivism. The idea that scientific theories and models are idealized idealized descriptions from very particular points of view. They're not pretending to give an accurate description of how the world is. And then the fifth cluster was a bit confusing or surprising. We weren't sure how to really interpret it, but at least based on the average responses, those physicists agree with pretty much everything, every statement, except for the fictionalist statement. So they claim that the unobservable objects postulated by physics are only useful fictions. So that's the only claim that they kind of disagreed with. But then pretty much all of the other statements they more or less agree with, which we found confusing. But then again, I mean, there are a lot of interpretations for these results. Aside from the averaging effect, of course, I think when you look at the individual answers, of course, many of them do disagree with a lot more statements. But even so, I think for those who broadly agree with all these statements, it can just be a matter of just being undecided, and that for physicists who have never really thought about these questions, they might read all these statements and think, yeah, I can think of a way that might be true. Like I can kind of see how that view might be a good view. So So yeah, we're not really sure, but there are many ways, of course, of interpreting this.
Yeah, the fifth cluster is kind of interesting. Like the kind of uncharitable interpretation is just like they're incoherent, they're inconsistent,
Yeah.
or they've not really made their mind up. Maybe
Mhm.
that's maybe a slightly more charitable interpretation.
Mhm.
But I think there's also just the possibility that these things are so complex, and like you said,
Exactly.
only 30 questions is like sounds like a lot, but there's just so many nuances to this. One question that got me thinking in particular was the one about general relativity. Let me just find it, which was general relativity teaches us about the nature of space time. So I guess that's guessing to, is one a theory realist? But I think of a previous guest of mine, Julian Barber, who is a realist, and he would believe in not only quarks, but he would believe in, I don't know, uh, you know, quantum mechanics as a theory, but he doesn't believe in space time because he's like, okay, well, just all of our best physics, although a lot of physicists sort of like talk in terms of space time, that's kind of a useful um, circumlocution, right? And what's really going on is there's nothing there's no entity called space time, and our physics doesn't require it. There's just relative positions of objects, and there's just relative configurations, and that's all you need for space and time. So kind of in the Machian tradition, but he's not a otherwise he's a realist. You just think that's not part of the thing. So yeah, I wonder how many of that fifth group, the kind of hard to understand one, or it might come down to subtleties like that. But to recap, we've got these 5 clusters that naturally emerge, and I really like the fact that you used this k-means clustering, and also and also other machine learning techniques to figure out what is the best k, what is the best number of groups to cluster on, because these are unsupervised learning techniques. So you don't go in and say, oh, this is a paradigmatic example of an instrumentalist person, and this is a paradigmatic example of this kind of view. Group everyone according to how close they are to those things. Rather, you just say, well, are there natural groupings? Like, are there just things that fall out of this data? So I think this is quite. These techniques are very commonly used in all sorts of places. Shopping trolley analysis on Amazon, where they're like, okay, what kind of consumer is this? Like, what stuff do they buy together? Without imposing a persona from the beginning. But it's certainly for me the first time that I've seen it used in philosophy. And I do think this could have wider application, actually, like in terms of trying to understand what are the philosophical positions out there, somehow trying to get away from how they've already characterized themselves. Could we actually find sort of more agreement between different philosophical positions by doing some kind of analysis, like clustering analysis of or conceptual analysis that clusters people together? But that's kind of by the by. But I do really like that use in this case. But so what drops out of that is these 5 clusters. You've got very instrumentalist cluster, and then you've got this sort of standard realist cluster, the moderate realist cluster, and then this quite interesting realist but also pluralist and perspectivalist cluster. So people who, like you say, they would say, yes, I believe in electrons. Yes, I believe that theories are getting us towards the truth. But I think you said it almost exactly. Scientific theories, they would agree with scientific theories and models are idealized structures that represent the world from particular and limited points of view. So sort of like the truth is out there, but there's, particular theories just give us different angles on that truth. I actually I took the survey myself, and I found that I came out in that cluster, which sort of it does make sense. I kind of feel like I am in that bucket, as it were.
So how did you find out which cluster you were?
I
I'm curious. Yeah.
I went through I took the survey,
Yeah.
and I didn't like you have all your R scripts and stuff hosted, but I lazily didn't bother running it through that. But I looked at sort of compared myself to the mean of the buckets in the table, of the clusters in the table that you have, and I think
Mhm.
that last question and a few others were real sort of edge case questions which separate
Yeah.
those different groups. So just
Yes.
looking at that, I'm pretty sure I'm in that
Mhm.
cluster, but if I was to do this properly, I would run your code. Um, and yeah, I have I found it interesting as well to see the relative number of physicists in each cluster. So yeah, as you said, you ran this for or you had 384 kind of respondents from physicists that were all valid. And of those, 61 were the instrumentalists. So that's something, I think, around 15%. The top bucket, and that's the smallest of the
Mhm.
clusters for the
Yeah.
physicists. So yeah, there's not many instrumentalists among physicists. And yeah, it would be really. I'd love to talk to some of those people in that bucket, because yeah, you learn obviously the most from the sort of revolutionaries or the
Mhm.
people on the in the minority views. Um, the biggest bucket is the standard realist one with about 25% share,
Yeah.
and then the plural and moderate realist views have about 20% each, and then another 15% or so for the hard to define cluster
Yeah.
five, uh, which is yeah. So did that? Yeah. Firstly, were you surprised by the clusters that were out there? Were you a bit surprised by the number of physicists falling into each, or did this kind of, in a way, in some ways, like it's quite nice to see these buckets naturally falling out? Yeah.
Um, we weren't very surprised. I guess we did expect physicists to be mostly realist, but we were glad. I guess we were happy to find that there was some variations, and that it's quite interesting to see with numbers, kind of also confirming um, the idea we had just based on anecdotal evidence and just the people we do know personally, that
Mm.
you have very different views, and that those instrumentalists do exist, and of course they are in the minority, definitely, but they still make up a good chunk of the overall group of physicists that we found. Um,
Yeah, I mean, 1 in 6 is not nothing. That's going to be
yeah,
like
it's
most.
definitely
And
not
did
nothing.
you? I don't know. Did you talk to any of those in particular, and were they surprised to find that they had different views to their colleagues, or uh, yeah, I don't know if you had, or also, I guess you would have personally known some of the respondents, and were there any kind of personal surprises there? Like,
So, I mean, a lot of the discussions we had with the people we do know were done before,
mhm.
like when the survey was in the making. Then we didn't actually look very closely at, once we had collected the data, we mostly did just data analysis, anonymized data analysis. Of course, out of curiosity, I did checks sometimes, like because we did offer the option of people giving their names and saying who they were. So and also their email address for follow up discussions and studies. So we didn't do any follow up. We did try to send the results of the survey to the people who had indicated an interest in knowing about it once the analysis was done. Um, But yeah, I don't think I was very surprised. I was just mostly interested in looking at what people thought about the survey in the comments. We had very different reactions. Some of them hated it, some people loved it. Um, which is good, I guess, because we also didn't want to have a sample bias where the people taking the survey are already those who are very much interested in those questions and have thought about them a lot. So that's a worry that we had. That of course we sent out the survey to many physicists by email, and I think I can't remember what was the percent of those who responded, but of course it's definitely a minority. Maybe a fifth of the physicists actually took the survey, and we thought, well, of course, there is already some bias here, and that those people who had an interest in exploring these questions, but given the comments that we had, we still had people who were unhappy about those questions and thought they were meaningless and not interesting, and others who thought that was very interesting and they wanted the results.
Yeah,
But yeah,
yeah, that's interesting. Yeah, there's almost like a kind of nihilist position in addition to everything else, where it's like, well, maybe I'm a realist, maybe I'm an instrumentalist, but I really don't care, right? Like this is just not important to what I do. Yeah, and I don't know if that's really captured much in in the philosophy side of things. I guess that's just captured by the people who don't work on philosophy of science on these questions, right?
yeah, exactly. But I mean, even within philosophy of science, there was still the view that those questions are misguided and that
Mm,
we should just suspend judgments about this, or just be take what Arthur Fine called a natural ontological attitude. That
mhm,
means whenever physicists talk about some behavior of the electrons, we just believe what they're saying about electrons, and we're not asking any further questions about, yeah, but are those electrons out there, or are they just described by the theory? So we just kind of push aside these questions, and that is a view in within philosophy of science itself. So actually, even philosophers of science
mm.
can think that those questions are just misguided, which is a view in itself, of course.
Yeah, I think that I I think there are I can see that it irks some people because they're like, well, we should focus our, as a philosopher of science, I want to focus my time on sort of aiding the physicists, like untangle their thorny knots of,
Hmm.
where while they're concentrating on doing the mathematics, there's just conceptual work which they need help with in terms of
Hmm.
the classic case obviously is the interpretation of quantum mechanics, but interpretation of space and time, like I mentioned, and Julian Barber is certainly at the kind of bridging worlds of philosophy and physics on that question. And any time we spend thinking on just these kind of more, in a sense, more foundational issues of like what indeed are what indeed is physics delivering us is is time that we lose on these other things. But I think there's like enough. I hope there's enough like energy and people working on these things that we can look at both, because yeah, there's also a case to be made that actually this is potentially this is a little bit controversial here, but maybe we can find that the best physicists have, maybe there's like a particular stance out there which is more conducive to doing physics, and it is quite intriguing that people with more experience, there is a slight correlation
Hmm.
with getting becoming more realist. Now, it's hard to know whether that's just they've got more ingrained and set in their ways, or maybe
Yeah.
it's that like maybe being more realist helps them do
Hmm.
their job. That's a very hard. That's going to take more than 30 questions to figure out. But
Yeah, of course. Yeah, that would require another follow-up study, but it's an interesting question, and we, of course, yeah, we try to be open about the different interpretations and kind of non-committal, because it's, at this point, is speculation,
Mm.
to wonder why there is this correlation. And actually, we were discussing it a few days ago. We were a bit surprised. Some people expected the opposite, actually, because we apparently, they see it within the PhD cohorts that first-time PhD students start their PhD very enthusiastic about physics and thinking that they're gonna uncover the mysteries of the universe
Right.
and find out
Right.
deep truth, and then slowly, as they do the research, they realize that uh, they're just manipulating phenomena, data, and just through so many layers of theory and experimental data processing and things like this. And I have, like, based on, again, very anecdotal evidence, I have a friend of mine who said exactly this.
Mm.
He The way his view evolved from the start of his PhD to the end of his PhD is actually from extreme realist to moderate, or maybe even more anti-realist. And but then, of course, those who go on to have a career in physics, and become professors, then maybe it is less surprising that those tend to be more realist, because maybe they're the ones who are also the most convinced that what they're doing is really uncovering something deep, about nature and how it works, rather than a more instrumentalist view that they're just predicting things. And yeah,
Yeah.
so it makes
Yeah.
sense. But yeah.
Yeah. I guess, one kind of practical learning from this is perhaps that, if you're, once you get over the hump of your initial deception of doing a PhD and it, physics not just delivering you nature on a plate, if you go into a career in physics, it won't end up making you jaded, at least in terms of your perception of scientific realism. So that's some practical career advice for people who are thinking of undertaking a career in physics. You're probably not going to be driven to think, oh no, I'm just working with fictions now. And another, like, really practical question that you snuck in, which I think we can learn from, is this. Let me just look the question up, but it's the one
About
on
the
the
LHC.
LHC. Yes, we should build a particle collider that is bigger than the LHC,
Mm-hmm.
and I think you found, like, well, maybe describe what you might expect to find, or what was the, I guess, intent of putting that question in.
Yeah. So that question was Hannah's idea, that she thought, one of the criticism of the realism anti-realism debate in philosophy of science is that it doesn't have any practical implications. So that's one
Right.
of the reasons why some philosophers might be just, it doesn't make any difference to how science is practiced in the lab, and it just doesn't make any difference to the world whatsoever. So we might just want to drop these questions. And so she thought that, on the contrary, being a realist or an instrumentalist might have very practical implications about what kind of projects are funded and how we direct our research towards certain avenues of research or not. And so she her hypothesis was that physicists who tend more towards realism would also tend more than the others to agree with the idea of building a larger particle collider. Of course, it being understood that there are many factors at play. So, of course, it's not the idea that this is the only factor that will influence one's positions on this. Of course, it's a primarily economic question. Those particle colliders are extremely expensive to build, and you would have not only to think that this is where our money should go, rather than other projects. Maybe you think that other projects are worth funding. Maybe you think that climate change is a more pressing issue, and that even if you're very, very realist about what these particle colliders might discover, you might still have other views, political views that would lead you to prefer funding other projects. So we actually got a pushback from a reviewer on this question. The reviewer who wanted us to scrap the question from the study, saying that there are just too many factors at play here, and realism and anti-realism doesn't seem to be relevant at all. But since we did find a weak correlation, we did want to maintain this result, or at least to present this result. But again, yeah, it is a weak correlation. So, but it does indicate that there is at least some sense in which those physicists who are more realists might be a little bit more inclined to build a bigger particle collider. And we did think also that, for example, the physicist Sabine Hossenfelder is self-described instrumentalist, and also one of the big opponents of building a bigger particle collider. She's one of the main critics of the kind of experiments that are done in this, for the main reason that she thinks they're not going to find anything, and it's a bit useless. And so we thought, well, maybe there's a relation between her instrumentalism and her view on building bigger particle colliders. And I did email her asking about this, and she actually said no. So, see, there's a lot of nuance here, but she actually said for her there is no relation between the two. She thinks the main factor at play, or the main reason why someone might be inclined towards or against bigging these is the economic factor. So to take with a grain of salt, but still, it's interesting to see that it might have some practical implication.
Yeah, I think, absolutely. And like you say, I mean, you wouldn't expect to find a very strong correlation, just given how much noise there is in terms of the numerous factors that can influence this. And one might just be like, I don't think we're going to, I'm a realist, but I don't think we're going to find any new particles. So
Exactly.
let's spend our physics, let's spend our physics research money on other things. But yeah, I think it does at least illuminate the principle, though, that there is, these attitudes, potentially do have an influence over the direction that science takes. Like, is it just, like, are we just using it as, and the very classic statement in instrumentalism is like, it's an instrument for, helping us do stuff, helping us, it's meant to be of use to us. Whereas a very kind of, and one doesn't have to hold that view as an instrumentalist. One can be an instrumentalist and just say, okay, well, no, it doesn't have to be useful. It just have to be kind of verifiable. And if we need fictions that aren't themselves observable as part of that, then that's fine. But I'm not going to include them in my ontology as having the status of true or real or unreal things. And whereas the kind of very strong realist position will be, well, or could be, might be at least associated with an idea of doing science for science's sake. Although, again, don't have to be correlated, but one can sort of see why they might be. Very interesting. That's great that you emailed Sabine Hossenfelder. It reminds me of, and I was thinking about this when I came across this survey the first time, about Chris Fuchs, who is the kind of one of the instigators of the cubism in interpretation of quantum mechanics, which I've had a previous guest on this podcast, Rudiger Schack, who is another of those sort of leaders of that interpretation. And for many years, he's been emailing lots and lots of physicists kind of canvassing their views on the Everest interpretation with a very specific, well, he's been asking lots of things, but one of the things that he asks is, before you came up with this theory or this kind of breakthrough, I don't know, Shor's algorithm, were you, modern Shor, thinking of the many worlds interpretation of quantum mechanics? Like, did it sort of conceptually help you in coming up with that? Because one of the weaker arguments that Everettians put forward is, oh yes, like, if you think in these terms, it's going to be fruitful. It's going to help you do science. And I think Chris Fuchs's informal survey, at least, seems to suggest, well, there's not really a correlation there. Like,
Okay.
at least for this. But he's a little bit, I think he would agree that he's got a dog in this fight. So, but I can buy that. Nonetheless, his conclusions or his surveys like correct in those terms. So clearly, I certainly believe that the opinions that one has do have some kind of bearing over the research that one's doing. The sort of more foundational opinions have a bearing on that.
Yeah, but yeah, I mean, there is the added complexity that whether you're a realist or instrumentalist about theories and what they say about the world, you might have different views about what the goal of science is. So when I described the standard realist view and the standard instrumentalist view, I put together the view that the realist would think that science is about describing, representing the world as accurate as possible, and that is somehow connected to a view of the goal of science as doing science for science's sake, and we're just trying to discover how nature works, regardless of its possible applications. Whereas the instrumentalist would more tend to be to both have the view that theories are not getting at anything deep about the world, but also that it's not the goal of science is not to uncover the inner secrets of nature, but rather to I think it was Ernst Mach who said to produce a means of orienting ourselves in nature. Science is continuous with biology, and we just need a means of adjusting and adapting to our environment, and that's what science does as well. But those can come apart. So you can be a realist about science, what scientific theories are and what they say about the world, and still think that science should be geared towards technological applications, for example. But you can also be an instrumentalist about scientific theories and still think that the pursuit of science for science's sake might be good as a proximate goal, although the ultimate goal is to produce something that is useful for humans. But a lot of the discoveries, of course, of science were down the line from inquiries that had absolutely no technological applications in mind. So, I mean, again, we were discussing this a few days ago with my old supervisor, Hasok Chang, who was saying that electromagnetism is one example of a type of inquiry that was purely science for science's sake, and apparently, I mean, it's not clear whether this is historical fact, but Faraday was criticized by some minister by saying, what is the point of your science? What is the point of what you're doing? And in the end, of course, his research on electromagnetism then led to all the technological advances based on electricity, which completely transformed our society. And so you could still be an instrumentalist about science and still think that pursuing science for science's sake and including fundamental physics might down the line produce very, very useful applications. So again, this is one of many ways in which the picture can be complicated.
Yeah. I'm reminded in that example of just one of my favourite anecdotes is like, Rutherford giving this public lecture saying it's a fool's errand to try to harness the power of the atom, and the very next day, like Leo Szilard reads that in the newspaper headlines, and realizes it and comes up with the idea of the chain reaction, which then delivers the atomic bomb and also
Of
nuclear
course.
power stations. So yeah. But I'm glad that you brought us back to just the kind of fundamental question of, or the idea of instrumentalism, because another nuance that I want to maybe touch on briefly is, we presented instrumentalism as this clearly anti-realist stance, but you've also argued elsewhere that actually within instrumentalism itself, there is room for realism, or a realism of sorts, I guess. So, can you kind of talk us through that a little bit?
Yeah, I mean, there are, just like there are many ways of being a scientific realist, there are many ways of being instrumentalist, and how historically this position has been ascribed or self-ascribed by philosophers of science. And so I would say, I mean, what we think of when we think about instrumentalism is the position of Henri Poincaré, for example, or Pierre Duhem, who thought that talk of electrons, I mean, although Henri Poincaré did come around and change his mind later, but the idea is that when we are describing these particles that we can't observe, we're just talking about useful fictions that help us describe and predict observable phenomena. And the view of most instrumentalists today is still somehow in this line that whenever we go beyond what is merely observable, we should at the very least suspend beliefs about whether what we are saying is tracking anything real or not, or whether it should be interpreted literally or not. And yeah, so yeah, but one of my articles on John Dewey's instrumentalism shows that there is another way of being an instrumentalist, and John Dewey is actually as far as I know, he is the one who coined the term instrumentalism, instrumentalist theory of knowledge. And so yeah, again, it's a more complex view where we do talk about all the means of scientific inquiry, including formulating hypotheses, proposition theories, models. I mean, he didn't talk about models at this time, but that's what we would today think of as models, as tools and instruments that serve certain purposes. They're not just mirrors of nature, of what is happening. There are theoretical constructions that we built for certain purposes, but that doesn't mean that then we have to say they're just useful fiction, they're not getting at anything real. The model of an electron and how it behaves can be used in such a way that you can agree that electrons exist, and you're not saying that the model picks out or is isomorphic to this entity that has the same mathematical structure, for example, in the world, and that we happen to find and isolate from its environment. But we can still say that electrons exist in the same way that stars exist in galaxies and the core of the Earth, which are all entities for which we have to infer or base our models on the basis of a lot of inferences. So yeah, there is. I mean, I would say, of course, his kind of realism would be maybe closer to the internal realist version, but that's not to say that electrons only exist when we talk about them, for example. But because the model of an electron is so useful, we can say that it is getting at something, phenomena that we are successfully describing in such and such a way. So definitely for the view that, I think the statement that you did call instrumentalist, but I think it's a minimal realist view that, there is something in the world, there is a phenomenon in the world, very real, that you can call patterns or something that, that we would call electron, that we would theorize as electron, and yeah, I think that is a form of realism. It's a maybe more minimal realism, but it is definitely compatible with the broadly instrumentalist view of the means of science.
Yeah, that's I think it was. Yeah, you're right. So I was mischaracterizing that. So there is something in the world that behaves like what we would define as an electron. So it's.
I would say it's compatible with a lot of views. This statement. Yeah.
It's, and I guess that kind of like plugs in with Dewey's more broader philosophical position as a pragmatist, that the things that we should accept as real or not real are the things which are giving us some proving useful, I suppose, and in and turning away from, again, the kind of representationalist theory of truth. And I think it's very useful to understand that even instrumentalism, one can kind of pitch it, or there are ways of thinking of it as compatible with realism. I wanted to, I was curious, what did you take the survey yourself, and where you came out?
I did take the survey, and I was actually trying to find this before the start of the interview, and I did find myself. However, I don't know which cluster I was assigned to. So, unfortunately, I'm not able to say which cluster I ended up in based on the cluster analysis. I have the list of individual answers for physicists and which cluster they were assigned to, but not for philosophers, because obviously the clusters we did based on the physicist answers. So the cluster analysis was made for physicists, and then we assigned as best as we could. I mean, as best as we could. I guess this is all done again with statistical methods. Philosophers into these clusters, and unfortunately, I don't have the individual breakdown for this, so I actually don't know.
But
I mean,
how do you think of yourself?
So looking back at my answers, because again, I can also change my mind sometimes, and that is one of the difficulty of the survey, and why it's so important, I think, to have a big sample size, because there is a lot of noise and a lot of ways in which, depending
ask me
how
again
I
tomorrow if
interpret
electrons
this.
exist.
I mean, I
certainly
think
some of
I
these
would
questions.
be, I would be either in the moderate realist cluster or in the perspectival realist cluster. Hard to tell, because I do agree with the, I indicated high, like 100 for perspectivism and some pluralist statements, but was maybe a little bit more moderate with some of the realist statements. So I'm not sure in which cluster I would have been assigned, but probably one of these two.
Yeah, I think it's interesting that even for people like yourself who think a lot about these topics, like, it can be hard to answer these questions. because, and I mean, I think that's a good thing, right? There's like maybe less, like, while it's possible to cluster people, there's maybe less tribalism than we might think, and there's, I'm sure, lots of agreement on particular statements between clusters as well. So that's a rather nice thing. I do want to add, and I emailed you last night about this, about I found it really fun to ask ChatGPT these questions, and
Yeah.
I was really surprised how it came in pretty close to your answers. So I asked it, answering from the perspective of a physicist who, professor of physics who has been working for 10 years in the field, and then just gave it the string of questions. And let me see if but yeah, it did the kind of classic ChatGPT thing of never ranking anything like 100.
Right.
But it ranked pretty high for, like, it said our most successful physics shows what the world is really like. That was a 75. Physics uncovers what the universe is made of and how it works. That's a 90.
Yeah.
Electrons are
Excellent.
real was a 90. Sorry, electrons are real as toenails and volcanoes was a 90. Electrons exist was 95. So actually, yeah, it's interesting. That was the highest score it gave, was a 95, and it was on that entity realism point, which is,
Right.
as you mentioned, that was the thing where people tended to agree most, or perhaps give the highest scores.
Yeah.
And
what
then
was
when I
it
asked
for?
it to answer from
Yeah.
the perspective of a philosopher of science, it was like somewhat lower. So, but still above 50 in terms of how successful physics is. Showing us what it really was like 60. So yeah, I don't know what you make of those results.
I mean, probably based on its massive data training, there must have been a lot of claims that physicists tend to be more realist, and of course for philosophers of science, there is a lot more engagement with arguments for anti-realism that could only come from, or come mainly from, people who are philosophically trained, or know about these kinds of arguments, or are also historically trained. And so I guess it's not surprising that philosophers of science would come as slightly less realist, because they have more of a sense of how history of science evolved, and more of a sense of different arguments that are philosophical in nature. So philosophers are not making any claims about scientific theories and what physicists actually claim in their article papers, right? That's not the place for philosophers to say, you're wrong to say that this is how an electron behaves. What they're saying is that, well, this is a very useful way of thinking about things, but think about the fact that there are maybe an infinity of unconceived alternatives, theories that we haven't even started to entertain, theories that we haven't even thought about, in the same way that for a Newtonian physicist, they wouldn't even have dreamed of thinking about something like general relativity, or special relativity. So, and we could very much be in the same position right now. And so I think that the fact that philosophers of science have to engage with these arguments in the in the past decades, I think what we've seen is a lot of scientific realists have had to add a lot more nuance in their views, rather than just saying, yes, theories are true, or we can make an inference from empirical success to truth. Theories are so successful and they work so well, they have to be true because they're true. And because of the amount of discussions that there have been, and the amount of arguments that showed the flaws in these types of arguments, the scientific realist views have had to become more refined and a bit more nuanced. And now we have a lot of people saying, I am a realist, but with an hyphen. So, or like, I'm a perspectival realist, I'm a selective realist, I am. So now what you have is really this collection of different views that are slightly more refined. And so yeah, it's probably not surprising that ChatGPT picked up on these. Yeah.
Yeah, I mean, I think, yeah, like exactly what you were saying. Like there's so much kind of complexity to the messages of science. It's kind of hard to completely buy in and say, of course, like, yeah, I'm a realist. Like, science is giving us the truth of everything, because the really out there, cutting edge stuff. There's just so much uncertainty that we don't have even consensus among scientists yet, and we also know that our best theories are probably going to be a bit revised.
Yeah.
But in less cutting edge fields, not to disparage them, the circulatory theory of blood, that's not going to be overturned.
Yeah, absolutely.
And what's interesting is, it was a paradigm shift. It was a scientific revolution in the kind of Kuhnian sense, when we went from believing that blood was just produced in the liver and that it was kind of consumed everywhere and not sent back. So it was this kind of one-way flow. And it's also interesting to think that, from an instrumental perspective, like previously we couldn't really observe the circulatory system, but now it's something that I would think of as actually pretty observable. Like we have really good imaging machines that will just show us the full system of your veins, and I'm sure you can see them, pumping blood around, and so these things do shift, but sometimes they do end up in a steady state where we're going to be like, okay, no, this one is the ultimate one. So the kind of classic pessimistic meta-induction at some point maybe is no longer valid, right?
Yeah, absolutely. So a problem for the instrumentalists is first to say, well, there doesn't have to be a strict boundary between observable and unobservable, but they would have to explain why is it that our theories about dinosaurs and how they lived are probably true, although dinosaurs, at least how they lived at the time, is not directly observable. We again infer all of this from what we can observe today, which are just fossils, and similarly, we have other kinds of unobservable phenomena, like the core of the Earth. So we apparently know a lot about the core of the Earth, and yet obviously it's something unobservable. We could never go down there and know what is happening there, or observe directly what is happening there. So should the instrumentalists say that because those things are unobservable and a product of very complex inferences, does that mean that we should also be anti-realist about them? And probably their answer is no, but they have to explain why is it that they think some things we should suspend judgment about, or at least be, or even be anti-realist about, and others we shouldn't. So that's one thing. And then the other thing is what you said with the pessimistic meta-induction, that of course, looking at the history of science, we see a lot of very successful theories that turned out to be false, and that at the time were believed to be true. And so there are reasons to think that in the same way today, a lot of the theories that we believe to be true could be overturned in the same way. But first of all, that pessimistic meta-induction is relying as its premise on a historical claim about past theories being overturned. And there's been a lot of discussion in philosophy of science, in the history of philosophy of science, of these, how much of these theories have actually been overturned, and have they been expanded? For example, that is actually a few of the comments that we got in the survey was, well, Newtonian mechanics, for example, has not been refuted. So we did have the pessimistic meta-induction as one of the statements.
Is it a limiting case of general relativity and still
exactly.
kind of right, or is
exactly.
it
So now,
just wrong?
it is. We could say it's a limited case, and so of course we some of its ontological commitments or substantial claims about the nature of space-time or gravity or force are now considered false. But the equations are still empirically adequate for what's happening at a certain level, and but then there is the worry also, formulated by Thomas Kuhn and other philosophers, that it's very easy to be Whiggish about history of science and just to look at the history of science from our perspective and then see, oh yeah, of course, this is a limiting case. And so to reinterpret old theories in a way that fits with our current theories, but actually that interpretation was absolutely not intended by the physicists at the time themselves. So there's a lot of discussion here, but obviously there is some pressure on these instrumentalists to say that even our most successful theories now could be shown to be completely false, although it seems like we have more and more ways, we use them in more and more ways, and in ways that don't just predict or explain observable phenomena as we see them now, but predict novel kinds of phenomena that we hadn't even thought about, and yet those are somehow consequences of the theory. And so it seems that it's definitely getting at something. And
Yeah.
yeah.
This has been this has been a great kind of not only overview of your survey results, but I think a really good overview of these kind of foundational issues in philosophy of science, like what is realism, what are the stances out there, and the challenges for each of them. I don't know if you have any kind of final thoughts, or I don't know, maybe I'm intrigued what you're working on now, or next. More surveys or something completely different?
Yeah, no. So, I mean, that was really a first for me, doing this kind of empirical work, more like experimental philosophy. I found it really interesting, really difficult to do as well. We couldn't have done it without Christoph Sperber, he's a neuroscientist, so he's very well versed in all of these methods. So. So it was great having him, and I would be curious to do more of these studies, but for now, at least, I'm mostly doing more theoretical work, and I'm also not working specifically in philosophy of science now. I'm interested in conceptual disagreements at the moment, and I'm still interested in example of those conceptual disagreements within science, but outside of science as well. And actually, I mean, because I'm not a trained scientist, or I don't have a degree in science, I've always been a bit cautious about doing philosophy of science. I think thankfully, a lot of philosophers of science have a degree in science or have themselves been practicing scientists, and I think in order to do really good philosophy of science, it's better to know the topic really well and to be able to have first-hand knowledge of what is going on in science. Since that's not my case, I tend to be careful with this, and I'm really happy I did the survey, but I didn't take the route of going deeper into philosophy of science. But,
I think it's certainly the case that, and I agree, it is a good thing that there's many philosophers of science who are, generally first have done a degree in a science. So David Wallace, my former tutor and a guest on this podcast, first did a degree in physics, and I think he, got a stellar result in that, which would surprise no one who's spoken to him. And then he was did a DPhil in philosophy. David Albert is another example, I guess. In fact, David Albert was basically thrown out of physics because he was asking the wrong kind of questions, and they got fed up with him. But on the other hand, I do think it's important that people who are there's a lot of use in having people who are not in the weeds so much in looking at some of these questions, because you may be freer from some of the preconceptions. Like, we wouldn't necessarily trust the Pope's opinion of whether God exists, right? But I mean, that's a whole other can of worms. But yeah, so and particularly when when you're doing experiments to back up your claims. I think this is a really good example of how people without a degree in science can still dive into these debates in the philosophy of science. Well, I hope you do further surveys, and yeah, I'm really interested in your work in conceptual engineering as well, and look forward to reading about that. We probably don't have enough time to go into detail, but I can't help but ask you, can you give like a 30-second overview of what conceptual engineering is, and then we can maybe leave this as a teaser for another episode.
Okay, yeah, sure. So I guess conceptual engineering is many things, but mainly a new or considered new philosophical method or new approach to concepts. So philosophy deals with a lot of concepts like knowledge, justice, race, gender, truth. And one of the main ways of approaching these were either to try to do an analysis of the concept, breaking it down, for example, in necessary and sufficient conditions, what it is to have knowledge, what are the conditions for someone to be said to have knowledge, or looking at the phenomena itself. So just looking at cases of knowledge, trying to investigate what knowledge is. And both of these approaches take the concept for granted that we do have a concept that possibly tracks with the way we use the term, and we just want to discover what it is, or we want to discover its meaning or what it refers to. And conceptual engineering, as its label indicates, takes a more reconstructive approach to concepts. So the idea is that we have some concepts that capture some of the ways in which we think about something like knowledge, gender, race, but they might not be the right concepts to have, or we might criticize those concepts themselves, or try to redefine them, to revise them, or to expand them in new ways. And that's a really interesting approach, because it's considering that concepts are, in some ways, some tools or instruments that we can craft and recraft in a way that's useful. And I think it touches upon a lot of really interesting questions in every domain. That's a good thing that's what I like about conceptual engineering, is that in every domain we can ask those questions. Like in the domain of artificial intelligence, what kind of concept of consciousness or intelligence are we using here? Given that probably these concepts emerge to talk about human consciousness and intelligence, how can we then expand them or refine them in a way that might be applicable to non-human machines? But
yeah, I think that's a beautiful overview, and I really hope to return to this topic, as it is so continuous with some of the things we've been talking about in terms of, well, what is this concept of an electron? Right, we get to choose. Like, that's very common in science, but maybe we should be doing it more broadly. Céline, thank you so much for this conversation. I've really enjoyed it.
Yeah, thank you so much. That was a really nice conversation.